Hello, and thank you for tuning in to the TIA poster. This video will cover the poster contents and includes a live demo of TIA. First, let's meet the team. The TIA Research Project has 8 awesome members who helped with front-end and back-end development. Since this summer, we have gained 2 new members and expanded our research topics to achieve our next round of goals. But more on that later. Before we jump into the research, let's discuss the importance of cybersecurity. As our technological dependencies strengthen, it's no secret that cybersecurity threats and attacks are on the rise. Over the next 5 years, global cybercrime costs are expected to exceed $10.5 trillion annually. This represents the greatest transfer of economic wealth in history. Due to the staggering cost of cybercrime, the ability to defend, monitor, and understand the cybersecurity world is critical. For cyber analysts, having the right information without cognitive overload could lead to more effective decision-making in cyber operations. The world of cybersecurity is acronym dense. Here are a few that will be referenced during this presentation. First, STIX. This is a standardized language developed by MITRE and the OASIS Cyber Threat Intelligence Technical Committee for describing cyber threat information. Structured Threat Information Expression, STIX, can be represented visually for an analyst or stored as JSON and machine readable. CTI stands for Cyber Threat Information. CVE stands for Common Vulnerability Exposures. These are a flaw in software, firmware, hardware, or service component resulting from a weakness that can be exploited, causing a negative impact to the confidentiality, integrity, or availability of an impacted component or components. CWE stands for Common Weakness Enumeration. Weaknesses are flaws, faults, bugs, or other errors in software or hardware, implementation, code, design, or architecture that, if left unaddressed, could result in systems, networks, or hardware being vulnerable to attack. The CWE list and associated classification taxonomy serve as a language that can be used to identify and describe these weaknesses in terms of CWEs. A vendor is an organization, and a product is a commodity owned by a vendor. This research involves the development of a web application that compiles and graphically displays vulnerabilities associated with a specific software or hardware configuration. To truly understand the capabilities of TIA, let's go check it out. Currently, this application is running locally, but we have recently developed a Docker container for this application as well. Okay, when you first land on the TIA homepage, you'll see this cute little message. TIA does stand for Threat Information Assistant, and we'll head over to the graph page. So as I was mentioning, you'll select first a vendor, I'll pick on Apple, and then a product. So these are all the associated products from this vendor. We'll click on iOS. So the first tab is Vulnerabilities, and this will show you just a CVS type graph or table of the vulnerabilities. Each of these are linked to the National Vulnerability Database page as well if you're looking for a little more information. But I believe TIA encompasses quite a lot. The next tab is Visualizations. Here we'll see 2 different types of graphs. First, a bar chart representing, here's that word again, common weakness enumerations. I think this is helpful if you're an organization looking at your most common weaknesses. So here we'll see Apple has common problems with out of bounds write, improper restriction of operations within the bounds of a memory buffer, and use after free. Over here, we're looking at CVSS scores, and these are just showing the severity of a vulnerability. So version 2 and version 3 are just, as they suggest, different versioning scales. So here we'll see 8 medium, 5 high. Again, this is for the Apple iOS vulnerabilities. And if we hop over to V3, we're seeing now 2 medium, 2 critical, and 9 high. So the last tab, I think, is the most exciting. This is where we're getting that STIX, the Structured Threat Information Expression, graphed visually for us. So we'll have 3 unique nodes, an identity, an infrastructure, and a vulnerability. Our identity is always going to be the vendor, that's Apple. Our infrastructure is always going to be the product that you select, in this case, iOS. And then it'll graph as many vulnerabilities that comes back associated with that identity and infrastructure. So this visualizer just moves them around dynamically, hopefully to like make it easier to see, but you can pin any of these nodes and they will stop moving. So again, as you click on these nodes, you'll get to see their description, their name, and a little bit more information about them. The other neat part about this page, if you scroll down just a little bit, you'll see an export button. So as previously mentioned, STIX is machine readable in the form of JSON. And so when you export this graph and then open it, you're seeing the JSON that a machine can now ingest and understand and interpret. So if we head back to the slideshow, currently, TIA has information on 134 vendors and 351 products. With this information, TIA can create 359 unique STIX graphs with 3 unique nodes: identity, infrastructure, and vulnerability. Development on the next iteration of TIA has already begun. Here are a few of our top priorities. First, our vulnerability data comes from the Cybersecurity and Infrastructure Security's known exploited vulnerability database. What that means is that CISA has a database that we're pulling this information from. And in order to keep TIA current, we will automate data retrieval and cleaning. Second, we will focus on enriching STIX graphs, first by adding new node types such as malware and adversaries and attack patterns, and second, by providing more information for existing nodes. Third, we are integrating the Idaho National Laboratory's IX discovery tools to personalize your TIA experience. Fourth, as TIA becomes more personalized to a user's security needs, we need to ensure their private security data does not become accessible. Therefore, we are researching ways to ensure an individual can use this application without their data reaching the internet. Thank you for watching. I hope you enjoyed your virtual experience at CEDAR's 2022 Research Symposium.